Okay, good morning. So this time we'll tackle about the topic on statistics and probability for grade 11. So we have here the first topic, the random variable. So talking about random variable is usually, or it is a variable written using a capital letter, is a variable that assigns a numerical value to each outcome of the random event. It can be classified as discrete or continuous depending on whether the value is obtained by counting or by measurement. So it is being signifies that the discrete random variable, its outcome can be counted, while the continuous random variable, its outcome can be measured. Okay, so we have here discrete versus continuous random variable. Letter A, we have a fair coin is tossed 30 times, and the number of times we have here x as the variable that a tail appears. Now it refers to the outcome that the tail appears after tossing this coin 30 times. Now it is actually under a discrete random variable, since its possible values may be determined by counting. So using 0, 1, 2, 3, 4 until 30 as the number of times, no 30. So 0 is actually referring to the outcome that has no tails, no? Kanang wala gid siya tail, so therefore it is referring to all heads. Okay, letter B, a machine is run and the recorded time it starts to experience a glitch. So nadaot na siya. Y illustrates a continuous random variable since the value of the variable may be assigned using measurement. So talking about time, so its outcome can be measured. So that is belong to continuous random variable. We have here an illustrative example for the discrete random variable. A coin is tossed 3 times and let the random variable x that would give the number of tails. So in this experiment, so we are after on the number of tails. Now after tossing a coin 3 times, so we have the variable x that would give the number of tails. So we are asked to construct, letter A, the probability distribution including the possible values of x. So talking about probability distribution, this one is a table containing the outcome and its corresponding probability. Okay. So we have here the solution. So we all know that coin, it has two faces. So that's why we have here 2 as the base. Then to the power of 3 as the number of times that this coin is being tossed. So when we simplify that one, 2 to the power of 3, that is equivalent to 8. And 8 is referring to the sample points in the sample space. So next, we have here, okay, the individuality of each outcome. So we have 8 sample points in the sample space S. So first outcome, of course, in tossing a coin 3 times, so there is an outcome actually that all heads will appear. So we have 3 heads. The second one, we have 2 heads and tail. Then alternate then for the third outcome, head, tail, and head. Head, tail, tail, then tail, tail, tail. Then we have 2 tails and head. We have tail, head, tail, then we have tail and 2 heads. So these are the possible outcome into seeing this coin. Considering that there will be no repetition of the event no, in this samples, repetition of outcome in the sample points, sample space. Next is we have to get the probability of each outcome. So we have the first event is 3 heads. Okay, 3 heads, that is x is equal to 0, referring to the outcome that has no tail. So as what we observe in the sample space, there is only one outcome that has no tails, no, or no tail. We have the first outcome, which is the 3 heads. So probability of x is equal to 0, that is 1 over 8. Okay, that is 0.125. Next, probability of this random variable x is equal to 1. It is referring to the outcome that has only one tail. So we have head, head, and tail. Head, tail, head. Then in the other one, we have tail, head, head. So therefore, there are only 3 outcome that has one head, one tail rather. Okay. So 0.375. Next, probability of x is equal to 2. This one is referring to the number of tails in the outcome. Duha ka tails. So we have head, tail, and tail. We have tail, tail, and head. Then we have tail, head, and tail. So we only have three outcomes in this sample space. So we have 3 over 8. That is 0.375. Next one is probability of x is equal to 3. This one is referring to the number of tails, meaning tulo ka tails. So as what we observe in here, from the sample space, we only have one outcome that has 3 tails. So we have tail, tail, and tail. So we have one only. So 1 over 8, that is 0.125. So we are done getting each corresponding probability of every outcome. So we can now make a probability distribution from these given values. Okay. The first row, we have number of tails referring to x. We have 0, 1, 2, and 3. Because 0, we include actually 0 because there is an event or outcome that has no tail. Then the second one, there is actually an outcome that has one tail only. Then the third one, which is 2, there are actually outcome that has two tails. And the last one, we have 3 because there is actually an outcome that has three tails. Then the second row, probability of x, meaning corresponding probability of every outcome. So we are done getting that one. So for 0, we have 0.125. For 1, 0.375. For 2, 0.375. And for probability of x is equal to 3, 0.125. Next, letter B. What is the mean of this distribution? So we are actually also going to identify the mean of this distribution. So mean of the discrete random variable, mu or m, is the central value or average of its corresponding probability mass function. It is computed using the formula. So we have here mean of this distribution is equal to the summation of x sub I, where x sub I is referring to each outcome times probability of each outcome. Okay? As I approaches to 1, or where I starts with 1 to n, depending on the number of times that this experiment is being utilized. Okay, next. From that one, okay, using that formula and this given probability mass function or table, so we can now compute for our mean. So we have here, using that formula, we have 0 as our x sub I, multiplied its corresponding probability, 0.125, plus the second outcome, which is 1, times its corresponding probability, 0.375. The third outcome, or the third one, we have 2 times 0.375, plus the last one, 3 times 0.125. If we're going to simplify that one, that is corresponding to a value of 1.5. That is for the mean. Letter C, what is the variance and standard deviation of this distribution? Okay. Variance and standard deviation are two values that describe how scattered or spread out the scores are from the mean value of the random variable. So the variance, denoted as sigma squared, is determined using the formula sigma squared, or population variance, is equal to the summation of x sub I, meaning the outcome, minus the mean of this outcome to the power of 2, where I start from 1 to n, multiplied by its corresponding probability. And the standard deviation is the square root of the variance. Thus, sigma is equal to square root of sigma squared. So that is actually the formula for computing the standard deviation. Okay, from using the table below, we can now compute for the variance and standard deviation. So we have here the probability mass function as what we obtained from our first concept, no, in the experiment. So we can now use this formula to identify first the variance, because the standard deviation is very simple to compute when we are done computing for the variance, because it is just the square root of the variance. So we have here for the variance 0.125 times 0 minus 1.5 to the power of 2. So 0.125 actually is the probability, no, kanang p of x, times the quantity of 0, which is referring to the first outcome, minus its population mean or the mean, which is 1.5 to the power of 2. plus the second probability 0.375 times the quantity of 1, which is referring to the second outcome, minus 1.5 to the power of 2, plus the third one, which is 2, and its corresponding probability is 0.375 times 2, which is the third outcome, minus 1.5 to the power of 2, plus the third one or the last one, 0.125 times 3 as its corresponding outcome, minus 1.5 to the power of 2. So simplifying with that, these given quantities, we have here 0.75 as the value of, or as our standard variance, variance of this probability mass function. So we already have the variance, so we can now compute for the standard deviation. So we know that the standard deviation is just the square root of the variance. Okay? Therefore, the variance is sigma squared is equal to 0.75. Thus, the standard deviation is sigma is equal to square root of 0.75, which is equivalent to 0.87. So 0.87 is the standard deviation, while 0.75 is our variance. Okay. So we are going now to move on the application of the discrete random variable or expected value. So this expected value is actually referring to the mean of this random event. Okay. So we have here expected value. Suppose that the random variable x, assume I, the number of possible values we have here, x sub 1, x sub 2, x sub 3 until x sub I. And the corresponding probability of each value is given by p of x sub I. Okay, meaning the corresponding probability of the outcome x sub 1 until x sub I. Then the expected value for x denoted by e of x is equal to the mean value of the probability distribution. So meaning we are just going to use the concept that we used before or previously from the mean. So thus, the expected value formula is equal to summation of x of I times probability of x of I, where I start from 1 to x. Okay, so the same formula that we used before. Okay, illustrative example. Okay, a card is drawn at random from a deck of cards consisting of cards numbered 1 through 5. A player wins 100 pesos if the number on the card is even and loses the same amount if the number on the card is odd. What is the expected value of his winning? Okay, as what we observed that there is a deck of cards. Now, a card is drawn at random from a deck of cards. So it is numbered 1 through 5. No? Then we observe that the player will win on 100 pesos if the number on the card is even. So first we have to identify the probability that the player will win also, no? Which is how many even number from 1 to 5. So we have 2 and 4. So 2 out of 5, no? While the probability of losing this game, no, is same amount, which is 100, but when it happens when the number on the card is odd. So how many odd are there from the number 1 to 5? So we have 1, 3, and 5. So there are only 3. So 3 out of 5. So meaning the probability of losing is bigger than the probability of winning. So we are asked also to identify what we are going to ask in here. We are asked to identify the expected value of his winning. Okay, so we have now the solution. Of course, this is now the outcome or the probability mass function corresponding to the given equation. X is referring to the number of the outcome, no? Okay? Ano yung outcome? Meaning, the player will win 100 when the number on the card is even. So, 2 out of 5, meaning the probability of winning is 2 over 5. Then we have minus 100 or negative 100 because the player will also lose same amount when the number on the card is odd. Okay? So, therefore, 3 out of 5 is ang iyang probability. Okay? So now we can now compute for the expected value. Okay? The expected value is equal to 100 times its probability, which is 2 over 5 plus negative 100 times 3 over 5 as its corresponding probability. So 100 divided by 5 is 20 times 2 is 40. Okay? Next, minus, we have here 100 divided 5 is 20 times 3 is 60. So 40 minus 60 is negative 20. So there is actually what the meaning of this quantity, which is negative 20. No? The expected value is negative 20. Thus, the player is expected to lose an average of 20 pesos in the game. So, meaning that is expected, no? Because as what you observe also that the probability of losing is greater than the probability of winning. Considering that there are more number to or more odd number in from 1 to 5 than even number. So, bigger yung probability in losing this kind of game. So, I hope that this video will help you particularly in answering your activity similar to this one. Thank you so much and God bless.